Tonight, I want to redraw the map in your head, because the map in your head, the one we all carry, the sun in the middle, 8 planets around it, Neptune at the edge, and then nothing. That map is wrong. Not wrong in a small way, wrong the way an old chart is wrong when it ends at a coastline nobody ever sailed past. The solar system does not end at Neptune. Past the last planet there is a third zone, a vast, ring-shaped country of frozen worlds, wider than all the space that holds every planet you have ever heard of, holding more objects than every planet, moon and asteroid you learned in school combined. Astronomers believe it contains hundreds of thousands of icy bodies larger than city size, and perhaps 1 trillion comets, the deep frozen leftovers of the solar system's own construction, drifting in the dark beyond Neptune, where the sun is just a fierce, cold star. And here is the thing most people don't realize. That crowded frontier is also, at the very same time, one of the emptiest places humanity has ever measured. When our fastest spacecraft crossed it, the emptiness out there was so complete that mission planners had to borrow the most powerful telescope in existence just to find one single stone for it to visit. Hundreds of thousands of worlds, and almost perfect nothingness, both true at once in a place your mental map marks as blank. Tonight, we are going out past the last planet, into the solar system's attic, where the original building materials of everything, including you, have been kept in cold storage for 4.5 billion years. By the time we come back, the solar system you fall asleep in will be a great deal larger than the one you woke up in this morning. Now, let's begin. First, settle in, get comfortable, and let the day put itself down. Maybe you are already half under the covers with the lights off. Maybe you are lying awake with a mind that will not stop pacing. Or somewhere quiet in the middle of a night shift, keeping the hours company. However tonight found you, you are in the right place. Nothing out in the Kuiper belt moves quickly, nothing out there is urgent, and nothing about tonight requires you to stay awake for it. If you drift off somewhere between here and the edge of the map, that is the journey working exactly as intended. Let us begin with the shape of things, because the solar system has an architecture, and once you see it, you will never picture home the same way again. Think of the Sun's family as 3 concentric countries. The first country is small, warm, and crowded with rock. Mercury, Venus, Earth, Mars, 4 solid worlds huddled close to the fire, all of them orbiting within a couple of 100 million miles of the Sun. Astronomers measure these distances with a simple yardstick, the distance from the Earth to the Sun, about 93 million miles. Call that 1 yardstick. The entire rocky kingdom, the whole realm of solid ground and warm light, fits inside about 1.5 yardsticks. Then comes the second country, the realm of the giants. Jupiter at 5 yardsticks, Saturn at 9.5, Uranus at 19, Neptune at 30. This is the solar system most of us carry in our heads, and it feels enormous because it is. Light itself, the fastest thing there is, needs more than 4 hours to travel from the Sun out to Neptune. When we spent our night with Neptune, we called it the last planet. And it is. But the last planet is not the last of the solar system, not remotely. Because past Neptune, starting more or less at Neptune's own doorstep, 30 yardsticks from the Sun, the third country begins. It is not a line of worlds like the planets. It is a thick ring, a donut of space wrapped around everything, beginning where Neptune orbits and running outward to roughly 50 yardsticks from the Sun, with scattered outer reaches trailing far beyond that. Hold those numbers against each other for a moment, because this is the first quiet shock of the night. The first two countries together, every planet from Mercury to Neptune, all of it fits within 30 yardsticks. The third country, the one missing from your mental map, spans about 20 yardsticks of width all by itself, and its sparse outer suburbs stretch to 100 yardsticks and more. The region beyond the planets is on the same scale as the entire realm of the planets. It is not a fringe. It is not a border strip. It is a country as large as everything you thought was the whole world, sitting in the dark, past the last lighthouse, and almost nobody on Earth could name it before the 1990s, because almost nothing in it had ever been seen. Now, you may be thinking that you have heard this shape before, because the solar system already has a famous belt, the asteroid belt, out between Mars and Jupiter, and it is worth taking a moment to say clearly that the two could hardly be more different, because the comparison is the fastest way to feel what the third country really is. The asteroid belt is small, genuinely small. Add up every asteroid in it, every last tumbling mountain from Ceres on down, and the whole belt weighs a few percent of our single moon. The Kuiper belt outweighs it many times over, holds far more large bodies, and occupies a volume of space so much greater that the comparison becomes almost comical, a garden bed beside a continent. The asteroid belt is made of rock and metal, kiln-fired leftovers from the warm inner rooms of the solar system, baked, cracked, and collided into fragments over billions of years. The Kuiper belt is made of ice, every fragile frozen thing the inner system could never hold on to, and they are leftovers of two different kinds. The asteroid belt is a construction site where a planet was prevented, a world that Jupiter's gravity never allowed to gather. The Kuiper belt is something grander and sadder, as we will see by the end, the remains of a vast, primordial disk that once held enough material to build whole planetary systems reduced now to its keepsakes. One is crumbs under the table of the giants. The other is the pantry the whole feast was cooked from. So when you hear the word belt tonight, do not picture the movie asteroid field, boulders tumbling past cockpit windows. Picture instead a cold, dark, nearly motionless nation of sleeping snowfields the size of counties and countries, spread so thin across so vast a ring that its citizens have never seen one another. And picture it starting just past the last planet's porchlight. This third country is the Kuiper belt. The name is odd, and we will get to the strange and slightly unfair story of how it got that name, because the man it honors argued, in the very paper that made him famous here, that this region of space should be empty. For now, hold the picture. A ring of deep, frozen bodies circling the sun beyond Neptune, each one an original brick from the solar system's construction site. Not rock, mostly, like the asteroid belt between Mars and Jupiter. These are different things. Out past Neptune, it has always been so cold that the soft, volatile materials the inner solar system boiled away. Water ice, frozen methane, frozen ammonia, frozen nitrogen, frozen carbon monoxide. Out there, they are as hard and permanent as granite. A body in the Kuiper belt is a snowball the size of a county or a mountain range, or in the largest cases, a world, a genuine round world with geography and moons, and in at least a few cases we will meet tonight, rings of its own. The belt holds the small change of creation, the pieces that were never gathered up into a planet, and that is exactly what makes it precious. Every planet has been melted, differentiated, weathered, and reworked by 4.5 billion years of heat and geology. The belt's citizens have simply waited, unmelted and unbothered, at temperatures a few dozen degrees above absolute zero since before the Earth was finished. The inner solar system is the finished house. The Kuiper belt is the builder's yard with the original materials still stacked where they were left, and the invoice still frozen to the crate. And the cold out there deserves a moment of respect because it is not a cold you can picture from anything in your experience. At the belt's middle distances, sunlight is between 1,000 and 2,000 times weaker than the daylight on Earth. The surface of a Kuiper belt object rests around -230 degrees Celsius, cold enough that the air you are breathing right now, the nitrogen and the oxygen of an ordinary bedroom, would freeze solid and fall onto the ground as frost. On the largest of these worlds, that is precisely what has happened. Their thin atmospheres come and go with their long seasons, sublimating into gas when their orbits carry them nearer the sun, then collapsing and snowing down onto the surface as the far end of the orbit takes them out into the deeper dark. Whole skies that fall down as frost and lie on the ground for a century, waiting for a distant spring to lift them again. That is the ordinary weather of the third country. Nothing about it is violent. Neptune, our last host, was fury wrapped in blue. The belt beyond it is the opposite of fury. It is the stillest inhabited by world's place the sun owns, a country where a single season outlasts nations, and where the loudest event in 1,000,000 years might be one pebble, somewhere, clicking against another. But before any of it could be explored, it had to be imagined, and before it could be imagined, one small, strange citizen of the belt had to wander into humanity's nets 60 years too early and confuse everybody. Because the truth, which almost nobody realized for most of a century, is that we discovered the Kuiper belt in 1930. We just did not know it. We found one member of a tribe of billions, and because we could not see the tribe, we called the scout a planet, and we spent the next several decades increasingly puzzled about why the 9th planet refused to behave like the other 8. The story of the Kuiper Belt begins, as so many good solar system stories do, with Pluto and with a 24-year-old farm boy from Kansas hired to do a job so tedious that nobody with seniority wanted it, who ended up finding the first piece of the largest structure in the Sun's family. The farm boy was Clyde Tombaugh. In the late 1920s, he was growing wheat and grinding telescope mirrors by hand in Kansas. Good enough mirrors that when he mailed his drawings of Jupiter and Mars to the Lowell Observatory in Arizona, unsolicited, hoping at best for advice, they offered him a job instead. The job was brutal in its monotony. The observatory's founder, Percival Lowell, had died convinced that a ninth planet lurked beyond Neptune, and the search for it had become an institutional obsession. Tombaugh's task was to photograph the sky along the zodiac, two plates of the same star field taken nights apart, and then feed the pairs into a machine called a blink comparator, which flips rapidly between the two images. Stars, being far away, hold still between the plates. Anything nearer, anything in the solar system, hops. Night after night, month after month, Tombaugh blinked his way through plate pairs holding hundreds of thousands of stars each, hunting for one dot in the swarm that jumped. Do that for a while and your eyes ache and swim. Tombaugh did it for the better part of a year. And on the 18th of February 1930, comparing two plates from January, he found it. A faint speck, far dimmer than Lowell had predicted, hopping exactly the small hop a body beyond Neptune should hop. The ninth planet. The observatory checked, rechecked, and announced it in March, and an 11-year-old girl in England suggested the name of the god of the underworld, the one who could make himself unseen, and the world put a ninth planet in its textbooks and considered the outer solar system complete. Pluto was the edge. Beyond Pluto, nothing. That was the map for the next 62 years. But almost from the beginning, the ninth planet was a poor fit. It was too small. Every measurement made it smaller, decade after decade, from Earth-sized to Mars-sized to, eventually, smaller than our own moon. Its orbit was wrong too. Every planet, from Mercury to Neptune, circles the Sun in nearly the same flat plane on nearly circular paths, like grooves in a record. Pluto's orbit is tilted 17 degrees out of the plane and stretched so long that, as we saw on our Neptune night, it actually dips inside Neptune's orbit for 20 years out of every lap. Nothing else in the planetary family behaved that way. For decades, astronomers filed Pluto under charming oddball, the eccentric at the end of the row, and a few of them, quietly, began to suspect something that would take half a century to prove. What if Pluto was not the last planet? What if Pluto was the first something else, the one bright member of a population, the way the first asteroid found? Ceres had been called a planet for decades, until telescopes improved and the rest of the asteroid belt swam into view around it. And everyone realized that Ceres was not a lonely world, but the largest citizen of a crowd. The suspicion has a paper trail, and it is older than you might think. In 1943, an Irish astronomer named Kenneth Edgeworth, a retired army engineer working mostly alone, published the suggestion that the region beyond Neptune ought to contain a large number of small, comparatively modest bodies, the unfinished remainder of the cloud that built the planets, and that from time to time, one of them might wander inward and appear in our skies as a comet. He was right in nearly every particular, and almost nobody noticed. Then, in 1951, the Dutch-American astronomer Gerard Kuiper, one of the most influential planetary scientists of his century, considered the same region in a famous paper. And here history plays its little joke. Kuiper reasoned that small bodies must indeed have formed out there in the beginning, but he believed Pluto was roughly Earth-sized, as the measurements of his day suggested, and a world that large, he argued, would have gravitationally swept the zone clean over the ages, scattering the debris away into the far darkness. In other words, the man whose name is now attached to the Kuiper belt argued, in the very paper that attached it, that the belt should no longer be there. He predicted its absence. The measurement he trusted was wrong. Pluto is tiny and never swept anything clean, and the belt survived. And by one of those accidents of citation and habit that scientists grumble about at conferences, the great ring of worlds ended up named for the man who reasoned it away, while Edgeworth, who got it right, is remembered mainly in a hyphenated version of the name that few people use. Some astronomers still make a point of calling it the Edgeworth-Kuiper belt. Tonight, having told the story once, we will use the common name, but you now know the small injustice folded inside it. For decades, the idea simply waited because no telescope on Earth could test it. A modest, icy body at 40 yardsticks is millions of times too faint for the eye, thousands of times too faint for the photographic plates of Tombour's era. The argument that finally revived the hunt came wonderfully not from the outer darkness but from comets. By the late 1970s, astronomers had a bookkeeping problem with the short-period comets, the ones like Halley's that return on human timescales. Comets are fragile. Each pass near the sun boils tons of ice off them, and after a few thousand orbits they crumble or burn out. On the age of the solar system, every short-period comet we see should have died long ago, which means something, somewhere, must be resupplying them. The great spherical Oort cloud, the comet reservoir at the true outer edge of the sun's domain, explain the long-period comets beautifully, the ones that fall in from every direction at random. But the short-period comets do not arrive from every direction. They hug the plane of the planets, the same flat disk everything else orbits in. In 1980, the Uruguayan astronomer Julio Fernandez published the crucial argument. A flat family of comets needs a flat source. Somewhere beyond Neptune, in the plane of the solar system, there had to be a belt of dormant icy bodies, slowly leaking members inward. The ghost of Edgeworth's idea re-derived from fresh evidence. The belt now had a theoretical reason to exist. What it did not have was a single confirmed member, apart from odd, unclassifiable Pluto. Theory said crowd, telescopes said blank. It is fair to ask why the confirmation took until 1992, when the prediction had been on paper since 1943. And the answer is that the belt had to wait for a revolution in the technology of seeing. For most of the 20th century, astronomy's detector was the photographic plate, a sheet of glass coated in emulsion, and photographic emulsion is a tragic instrument. It records, at best, a few percent of the light that falls on it. 90-some photons out of every 100 that crossed billions of miles to reach the telescope simply vanished into the glass unrecorded. Against those odds, a faint belt world was hopeless, its trickle of reflected sunlight thinned below any plate's threshold. What changed everything was the charge-coupled device, the electronic light sensor, cousin to the chip in every phone camera in your house tonight, which began reaching observatories in the 1980s. A good sensor of that kind wastes almost nothing, capturing most of the photons that touch it and in one stroke the effective power of every telescope on Earth multiplied. Worlds that had been invisible through a 100-inch mirror for 70 years became merely difficult. The Kuiper belt was not discovered because anyone built a bigger telescope. It was discovered because we finally stopped spilling the light we were already catching. There is a lesson folded in there that astronomy keeps reteaching, and that tonight will teach once more before we finish. The universe rarely hides things actively, it just waits for our eyes to improve, holding everything patiently in place like a page that has always been printed, waiting for better reading light. Enter two people with a telescope and an almost unreasonable supply of patience. In 1987, David Jewett, then a young professor, and Jane Liu, then a graduate student, decided to search the outer solar system systematically for the simple, stubborn reason that Jewett kept articulating when anyone asked why. If we don't do it, who will? The outer solar system appeared empty, he liked to say later, and it bothered him that nobody had checked whether it actually was. Understand what the search demanded. A body out at 40 yardsticks does not announce itself. It reflects a few billionths of the sunlight that grazes it. It creeps across the sky at a rate that barely distinguishes it from the fixed stars, and it hides among hundreds of thousands of star images on every frame. Jewett and Liu were doing Tomball's job again, but for targets 10,000 times fainter than Pluto, at the very limit of the best instruments of their era, first with photographic plates, then with the earliest electronic detectors comparing frame after frame after frame, night after night, on telescopes in Arizona, in Chile, and finally on the giant instruments atop Mauna Kea in Hawaii. They found nothing for 5 years. 5 years of applying for telescope time, flying to mountain tops, staring at screens through the small hours and finding, with immense care and rigor, blank sky. Colleagues told them, more or less kindly, that they were wasting their careers. It is worth lying still with that for a moment, because we tell the stories of discoveries and forget the shape of the years inside them. 5 years of professional courage spent proving nothing yet, over and over, on the strength of a bookkeeping argument about comets. And then, on the night of the 30th of August, 1992, at the University of Hawaii's telescope on Mauna Kea, a faint dot moved. It moved between frames at exactly the creeping pace of something 40 yardsticks out, far beyond Neptune, far beyond Pluto's distance that year. Jowett and Lou tracked it through the night, hardly letting themselves believe it, computing and recomputing the implied orbit as the hours passed. The dot was perhaps 100 miles or so across, a body the size of a small state, dark and reddish, circling the sun serenely out where Kuiper had said the sweeping should have left nothing. It was catalogued under the license plate designation of its discovery fortnight, 1992 QB1, and a word about those strange names is in order, because the belt is full of them, and they tell you something true about the state of the map. When astronomers find a new minor body, it receives a provisional tag built from the year and a letter code for the half-month of discovery, a bureaucratic license plate, and only once its orbit is nailed down over years does it earn a permanent number, and only then, at its discoverer's leisure, a name. The belt has been found so recently and is being found so fast that vast numbers of its citizens are still driving around on their license plates, worlds 50 and 100 miles wide, known to science only as strings of letters and digits, waiting decades in the queue for a name. We are that early. The country is that new. Jewett and Lou, for their part, tried to nickname their discovery Smiley after the fictional spymaster, but an asteroid had already claimed the name, and so the first citizen of the third country found on purpose still wears its license plate to this day, and with that single moving speck, however it was labeled, the third country of the solar system came into existence for the human species. Every claim about the region beyond Neptune, 60 years of speculation, Edgeworth's guess, Fernandez's comet arithmetic, all of it stopped being theory on that August night and became geography. The map had a new country on it, and the country had exactly two known citizens, an oddball explanet and a fresh speck with a license plate for a name. What happened next was the floodgate. Within 6 months, they had found a second object. Within a few years, dozens, then hundreds, every one of them confirmed the pattern. Pluto had never been alone. Pluto had never been an oddball. Pluto was simply the brightest resident of a country we had been staring past for 62 years, the one member of the crowd bright enough to snag in a Kansas farm boy's net in 1930. Today, the catalogue of known Kuiper belt objects runs into the thousands. The estimated population of substantial bodies runs into the hundreds of thousands. And the two people who spent 5 empty years refusing to stop looking are remembered as the discoverers of the largest structure in the solar system. When the history of astronomy in our era is written, the patience of Jewett and Lou will sit beside the arithmetic of Leverrier from our Neptune night, twin monuments to the two ways humanity finds invisible things. One pair found a world by calculating where it had to be. The other pair found a country by refusing to believe the map was finished. So what did the floodgates reveal? Not a uniform ring of rubble. A country with provinces, each with its own character, its own history, and its own relationship with the giant that governs them all. Because if tonight's journey has a returning character, a familiar face from a night we have already spent together, it is Neptune. The Kuiper Belt is not merely the region past Neptune, it is, in a sense we will keep discovering, Neptune's estate, organized by Neptune's gravity, pruned by Neptune's migrations, and patrolled by Neptune's long, slow lapse of the sun. You cannot tell the belt's story without the last planet standing quietly at the border, conducting. The first province is the one astronomers call, with unusual tenderness, the cold classical belt. Cold here refers not to temperature, though it is cold beyond reckoning, but to the orbits themselves. These are the belt's calmest citizens, circling between roughly 40 and 50 yardsticks out on paths that are nearly circular and nearly flat. Exactly the kind of untroubled orbits that bodies settle into when nothing has ever disturbed them. And that is precisely what makes the cold classicals extraordinary. Everything else in the solar system has been shoved at some point. Planets migrated, asteroids were flung, moons were captured. The cold classical belt, the evidence suggests, has never been shoved. These objects likely formed exactly where they orbit today and have simply stayed there, unshepherded and unscattered, for the age of the sun. They are the control group of the solar system, the one neighborhood where the original arrangement survives. They even look different. The cold classicals are redder than almost anything else in the sun's family, coated in what chemists believe are tholins, complex reddish organic compounds cooked slowly onto their surfaces by billions of years of radiation acting on simple ices. And they keep another secret, one of the loveliest statistics in planetary science. An enormous fraction of them come in pairs. Binary worlds, two bodies of similar size orbiting each other gently as they circle the sun together, like dance partners who never let go. In the crowded, violent inner solar system, such delicate pairings get ripped apart by close encounters. Out in the cold, classical belt, nothing has ever come close enough to cut in. The pairs that formed together in the beginning are still together. The quietest province of the solar system is full of couples that have been holding hands for 4.5 billion years. The second province we have already visited in a way on our Neptune night. These are the resonant objects, the tribes locked in gravitational rhythm with Neptune, and the greatest of their tribes is Pluto's own, the plutinos, the bodies that orbit the sun exactly twice for every 3 Neptune laps. Remember the choreography. Pluto's stretched orbit actually crosses inside Neptune's, which sounds like an eventual collision, and never will be, because the 3 for 2 rhythm guarantees that whenever Pluto slips inside, Neptune is far around the curve of its own path. What we did not dwell on that night is how many bodies share the trick. Hundreds of known plutinos and, by estimate, thousands more, all stepping to the same beat, all crossing the border safely on the same rhythmic passport. There are other tribes at other rhythms, 1 to 2, 2 to 5, 3 to 5, each rhythm a groove that Neptune's gravity has worn into the belt over billions of years. Picture the belt from above. If you could see the orbits drawn as lines, it would look combed, not scattered like dropped sand, but combed, streaked into families and lanes, the way iron filings arrange along the field of an unseen magnet. The magnet is Neptune, and the combing, as we said on that night and can now see from the other side, is the fossil record of Neptune's great outward migration, the era when the last giant ploughed slowly through this country, herding some worlds ahead of it into rhythm and flinging the unlucky ones away entirely. Which brings us to the third province, the one built from the unlucky. Astronomers call it the scattered disk, and the name is honest. These are the bodies Neptune threw. Their orbits are wild, stretched, and steeply tilted, some diving inward almost to Neptune's doorstep, before soaring out to 100 yardsticks or more, spending centuries of each lap in darkness so deep the sun shrinks toward the ordinary stars. The scattered disk is the belt's badlands, the wreckage yard of the migration era, and it is anything but a footnote. It is the probable source of most of the short-period comets the leaking reservoir Fernandez predicted, and it is home to some of the largest worlds in the entire belt, exiles of substance, as we will see when we meet Eris, the world whose discovery broke the word planet itself. If the cold classicals are the country's untouched heartland, and the resonant tribes are its rhythmic border families, the scattered disk is its diaspora, flung to the margins by the same events that built the order everywhere else. One more feature of the country's geography deserves a moment, because your mental picture is probably still too tidy. We keep saying belt, and belt suggests a flat ribbon, all the worlds circling in one neat plane like the grooves of a record. The reality is thicker and stranger. The belt has altitude. Its provinces differ, not just in the shapes of their orbits, but in how steeply those orbits tilt, and the tilts sort the population like layers in a terrarium. The cold classical heartland really is flat, a serene sheet of orbits tilted barely a few degrees, the unstirred cream at the center. But wrapped around that flat heart circles a second population astronomers call the hot classicals. Hot again meaning stirred, not warm, bodies whose orbits climb tens of degrees out of the plane, swooping high above the solar system's table and diving below it on every lap. They are interlopers of a sort, worlds that formed closer to the sun by the evidence of their grayer colors and their history, and were splashed outward and upward during the great migrations, coming to rest in the same region as the natives but never on the same level. So the true shape of the third country is not a ribbon, it is a donut, a torus thick enough that seen edge on from far away it would fatten into a lens, with a cold, flat aristocracy sailing calmly through its midline, while a scattered, high-flying population storms above and below it, the two classes sharing an address and almost nothing else. Even the belt's structure, in other words, is a fossil of its history, calm at the core where nothing was ever disturbed, agitated in every layer that the age of migrations touched. The country's very thickness is a memoir. Now, having drawn the provinces, I owe you the paradox I promised in the very first minutes of tonight, because it is time to stand in this country and feel how empty a crowded place can be. The numbers of the Kuiper Belt sound like congestion, hundreds of thousands of bodies larger than 60 miles across, perhaps 1 trillion comet-sized fragments. But now spread them through the volume they actually occupy, a donut of space 20 yardsticks wide and billions of miles around, thick as well as broad. Run the arithmetic and the congestion evaporates. The typical distance between substantial neighbors in the Kuiper Belt is measured in millions of miles. Millions. Stand on a belt world, and your nearest fellow citizen is not a looming shape in the sky. It is nothing. It is a point of light too faint to notice, lost among the stars, indistinguishable from the stars, a neighbor you will never see and could travel toward for years without reaching. The asteroid field of the movies, the tumbling boulders you steer between, does not exist anywhere in our solar system, and least of all, here. When the New Horizons spacecraft flew through the heart of this country, the most crowded region of the third zone, mission scientists were asked whether they worried about hitting something. The honest answer was that their problem was the opposite: years of flight inside the most populated ring of worlds in the solar system, and the challenge was finding even one single object close enough to photograph. Both facts we opened the night with are now standing in the same frame. The belt holds a nation of worlds, and it is so vast that the nation dissolves into it like a handful of salt in an ocean. If the numbers keep sliding off, and numbers this size always do, try carrying the whole country in a scale model, because the belt shrinks, honestly. Make the distance from the Earth to the Sun our yardstick, one single step. On that scale, the Sun is a bright marble sitting in the middle of a large field, and the entire rocky kingdom, all 4 inner worlds and everyone who ever lived on one, orbits within a step or 2 of it, each planet a mote of dust too small for any eye. Jupiter is a sand grain 5 steps out. Neptune, a slightly smaller grain, 30 steps out, about the far side of the field. And the Kuiper Belt is a ring of powder beginning right there at Neptune's grain and spreading out to 50 steps, a broad band of frost motes scattered through the grass, hundreds of thousands of them, each mote microscopic, each mote sitting alone a full hand's width or more from its nearest neighbor, which at that scale is an ocean of separation. Now step back and look at the model whole. A marble of fire in the middle of a field, a pinch of dust orbiting close to it, which is everything you have ever known. A few sand grains farther out, which are the giants, and then wrapping the whole arrangement a wide, faint ring of powder, wider than everything it encloses, thin as breath, reaching nearly to the edge of the field. That is the true architecture of home. The planets are not the solar system. The planets are the marble's inner ornaments. By extent, by number, by sheer share of the map, The Sun's domain is mostly this outer powder, mostly cold, mostly nameless, mostly unvisited, and the strangest part of tonight is realizing that the powder is not the background of the story. Around most of the field, the powder is the story. So let this be tonight's first long stillness. Come stand on one of them. Choose an ordinary citizen, a nameless body a few dozen miles across, out in the cold classical heartland, 45 yardsticks from the sun, and stand on its surface in the small hours of its century-long year. The ground under you is water ice hard as bedrock, dusted with methane frost, stained that deep tholin red, though you can barely tell, because the light is so low that color is mostly a rumor here. Gravity holds you like a suggestion. You weigh less than a bag of sugar, and if you jumped with real intent, you might leave forever. So you do not jump. You stand still, the way everything here stands still. Look toward the sun. You can find it instantly, the one overwhelming star, still hundreds of times brighter than the full moon of home, yet nearly 2,000 times dimmer than the daylight you were born under, a brilliant cold rivet in a black sky, casting your shadow long and faint across the frost behind you. Its light needed more than 6 hours to reach you here, half again the journey it made to reach Neptune on our last night out. Hold up your thumb and you can blot out the entire inner solar system, every planet, every ocean, every city, every person who has ever lived, hidden behind one thumb at arm's length. Now look the other way, outward, away from the fire. There is no far shore out there for 100,000 years of starlight. Just the deepening dark, the stars, and somewhere among those stars, invisible, your nearest neighbors, each standing in their own silence, millions of miles of nothing between each of you, a nation of hermits around one distant lamp. Listen. There is nothing to listen to. No wind, no settling, no tick of cooling stone. Sound needs somewhere to happen, and this world offers none. The frost at your feet fell before anything on earth had a spine, and it will lie undisturbed long after the continents have rearranged themselves again. Nothing here is waiting, because waiting implies something scheduled, and nothing is scheduled here for the next billion years. If you have ever wanted the universe to ask absolutely nothing of you, this is the place. Stay a while. The sun will not move noticeably tonight or this month. The century will turn before the season does, and when you are ready, we will go meet the giants of this country, because scattered through all this stillness, there are worlds large enough to have names and moons and rings and stories, and one of them ended the age of 9 planets. Before we meet the giants of this country, it is worth pausing to ask a question that sounds almost rude. How do we know any of this? The worlds of the Kuiper Belt are, as we just felt, points of light at best, billions of miles away, dimmer than anything the human eye could ever register. No telescope on Earth or in orbit can resolve the surface of a typical belt object into a picture. Even mighty Pluto, was never more than a smeared handful of pixels before New Horizons arrived. And yet tonight I have been telling you diameters, shapes, densities, moons, rings, frost cycles. Where does knowledge like that come from about worlds nobody can see? The answer is one of the quiet triumphs of modern astronomy, and it deserves its few minutes tonight because the belt was not mapped with cameras. It was mapped with shadows and patience. The master technique is called the stellar occultation, and the idea is so simple it feels like it should not work. Astronomers compute the path of a belt object across the sky years in advance and wait for it to pass, from our point of view, directly in front of a background star. When it does, the star blinks out. The world itself remains utterly invisible, but its shadow, cast by the star's light, sweeps across the earth like the shadow of a bird crossing a lawn, and wherever that shadow passes, the star vanishes for a handful of seconds. Now put telescopes in the shadow's path. Not great observatories necessarily. School telescopes, amateur instruments in back gardens, portable rigs driven to fence lines in the outback at 3 in the morning. Each observer records one thing only: the precise moment the star disappeared and the precise moment it returned. Each telescope, in other words, measures one chord across the hidden body, one slice of its width. Stack a dozen chords from a dozen sites, and the invisible world's outline rises out of the timings like a ship's hull rising out of fog, its size, its shape, even its roundness or lack of it, drawn entirely in interrupted starlight. It was occultation chords that pinned down Eris's true size and delivered the delicious verdict that it is a shade smaller than Pluto, yet heavier. It was occultation timing that revealed Haumea's impossible egg profile without a single picture of the egg. And it was occultations that produced the belt's biggest recent shocks, the rings. A ring, remember, announces itself as a pair of tiny extra blinks, the star stuttering briefly before the main body arrives and again after it departs, symmetrical winks a few seconds out on either side. When the teams watching Koa cross a star in front of telescopes scattered across the world saw those paired stutters printed identically in data from sites hundreds of miles apart, there was no arguing with them. You cannot photograph a ring around a world half Pluto's size at 4 billion miles. But you can catch it blocking a star for a fraction of a second, twice, from 2 continents, and know it is there as surely as if you had flown through it. Everything else we know arrives by equally sideways routes. Densities come from moons. Find a companion, watch how quickly it circles, and gravity itself hands you the main body's mass. No picture required, which is why astronomers greet every newly discovered Kuiper Belt moon like a gift, because each one turns a mute point of light into a world that can be weighed. Compositions come from spectra, the surface's reflected sunlight fanned out into its constituent colors, where every ice leaves fingerprints, the sharp signature of methane frost, the deep stamp of frozen nitrogen, the reddened slopes that betray tholins. Temperatures come from the faint heat glow the worlds themselves give off, measured by infrared telescopes as a warmth of a few dozen degrees above absolute nothing. And rotation comes from brightness alone, the gentle rhythmic flicker as an unround body turns, brighter, broadside, dimmer end on, a lighthouse signature, slow as breathing. Piece it together, and you can hold in your mind what no eye will ever see, an entire national census, sizes, shapes, weights, surfaces, spins, compiled for a country of invisible worlds by people watching stars blink from folding chairs in the dark. I find that image as moving as any spacecraft encounter, honestly. Humanity wanted to know the far country so badly that, lacking any way to see it, we learned to read its silhouettes against the lights beyond, one stolen second at a time. There is one more member of the Belt's extended family to meet before the giants, a tribe that lives not in the Belt but between, and they matter to tonight because they are the Belt caught in the act of arriving. Between the orbits of Jupiter and Neptune, in the country of the giant planets, astronomers keep finding icy bodies that have no business being there, worlds up to 100 miles across and more, on looping, unstable, planet-crossing orbits that cannot last. They are called the centaurs, half one thing and half another, like their namesakes, and dynamically they are exactly what they look like, Kuiper Belt objects in mid-fall. Each one was nudged loose from the belt or the scattered disk in the astronomically recent past, and each is now being handed from giant to giant in a gravitational relay that must end within a few million years in one of three fates: flung back out to the dark, flung into the sun's neighborhood to bloom as a comet and die by evaporation, or flung out of the solar system altogether, exiled to the space between the stars. The centaurs are the Belt's emigrants photographed mid-journey, and they carry their homeland's customs with them. The first of them ever found, Chiron, discovered in 1977, was so unclassifiable that it triggered a decade of gentle argument. It is the size of an asteroid. It sprouts a comet's fuzz of escaping gas when its orbit warms it, and occultation watchers have caught paired stutters around it too. Hints of encircling rings or shells of debris around a body barely 140 miles wide. Nobody in 1977 had a category for a ringed, gassing 100-mile mountain of ice wandering between Saturn and Uranus. Tonight, you do. It is a piece of the third country, on embassy, halfway down the long stairs to the sun. And when it finally blooms and burns some tens of thousands of years from now, some distant generation may watch it stretch a tail across their sky and never know they are watching the Kuiper Belt wave goodbye. The giants of the Kuiper Belt are the dwarf planets, and before we meet them, we should make peace with that term, because it was born in an argument that most people remember slightly wrong. We spent a whole night once on the story of Pluto's reclassification, so tonight we will not relitigate it, but the Belt's version of the story deserves one paragraph, because from out here past Neptune, the so-called demotion looks entirely different. It looks like a promotion. What happened in the compressed version is this. In January of 2005, a team led by the astronomer Mike Brown, sifting survey images at Palomar Observatory in California, found a scattered disk world so far out and so bright that when its size was first estimated, it appeared to be larger than Pluto itself. It was eventually named Eris for the goddess of discord, and discord is exactly what it delivered, because now the question could no longer be postponed. If Pluto is the 9th planet, is this new world the 10th? And what about the next one, found, and the next? The belt was plainly full of Plutos. Either the word planet was going to inflate until it meant nothing, or it was going to be fenced. And in August of 2006, the astronomers of the world, gathered in Prague, chose the fence. Pluto did not fail some test of worth. Pluto was recognized at last as what it had secretly been since 1930, the first discovered and most famous citizen of the third country. And Eris, the world that forced the question, is the reason the textbooks had to be reprinted. That is what we saw when New Horizons finally reached Pluto in 2015 and found not a demoted footnote, but a stunning, active world, mountains of water ice, glaciers of flowing nitrogen, a vast, bright heart-shaped plain, and a blue haze hanging over all of it. The belt's first citizen turned out to be one of the most beautiful objects in the solar system. The country makes worlds worth visiting. That was the lesson, and the rest of the giants only deepen it. So meet Eris properly. It circles the sun on a scattered disk exile's orbit, tilted hard out of the plane of the planets and stretched so long that one lap takes about 560 years, swinging from roughly 38 yardsticks at its nearest to nearly 100 at its farthest. Right now, it is near that far end, one of the most distant large objects ever observed in orbit around our star, so remote that from its surface the sun has shrunk to a point you could almost mistake for a bright planet. We now know Eris is a shade smaller than Pluto in width, but noticeably heavier, denser, a more tightly packed world, with a bright, icy surface and a moon of its own, Dysnomia, named for the goddess of lawlessness, the daughter of discord, which is the astronomical naming committee showing you it has a sense of humor. Eris's brightness is its own story. Its surface is among the most reflective in the solar system, and the leading explanation is the falling sky we spoke of earlier. Eris is so far from the sun that its thin atmosphere has frozen out entirely, snowed down onto the ground as a fresh, brilliant frost that will lie there for centuries until its slow orbit brings it near enough to the fire for the sky to rise again. A world that inhales its atmosphere for one part of its year and exhales it for the other, breathing on a rhythm of half a millennium. And lest that sound like an exotic malfunction, understand that it is the ordinary respiration of the belt's great worlds. Pluto is doing a slower, gentler version of the same thing right now. Pluto passed the near point of its orbit in 1989, the very year Voyager was flying past Neptune. and it has been receding into its long autumn ever since. And astronomers using those stellar occultations have been monitoring its thin nitrogen atmosphere ever since, like nurses charting a patient's breath, watching for the long-expected exhale. For years, the atmosphere defied them by thickening even as the world drew away from the sun, warmed by thermal lag, the way the hottest part of an afternoon comes hours after noon. The freeze-out is coming. The models still agree, some decades or a century hence, when Pluto's sky will largely close and lie down on the ground as frost until the 23rd century brings it near the fire again. Whole worlds out there breathe on the time scale of civilizations. It is worth remembering, whenever the belt is dismissed as inert, that its largest citizens are not frozen still. They are frozen slowly, which is a different thing entirely. Alive on a tempo we have to instrument our telescopes to even perceive. Then there is Haumea, and if Eris is the belt's lawyer, the world that forced the definitions, Haumea is its wild survivor's tale. Haumea is an egg, genuinely. It is one of the largest objects in the belt by mass, but it spins so violently, one full rotation every 4 hours, the fastest spin of any large world in the solar system, that it has been stretched into an ellipsoid, longer than it is wide, a world that would look, from a distance, like a pale stone egg tumbling end over end through the dark. Nothing that size chooses to spin like that. Something did it. Long ago, the evidence says, another large body struck Haumea, a colossal glancing blow, an impact that spun it up like a flicked coin, blasted much of its icy outer shell into space, and left behind not just the egg, but a family. Scattered along orbits similar to Haumea's own, astronomers keep finding smaller icy bodies whose surfaces are chemically alike, matching shards of the same ancient shell, a debris family drifting apart for 1 billion years or more, still recognizable as siblings. Haumea has 2 small moons, likely gathered from that same wreckage, and one more distinction that stunned everyone when it was found in 2017. Haumea has a ring, a thin, dark hoop circling the tumbling egg, the first ring ever discovered around a world beyond Neptune. Even out here, in the stillest country the sun owns, there was once a day violent enough to shatter a world's surface, spin it into an egg, strew its children across 1 billion miles, and hang a ring around the survivor as a souvenir. Makemake, the third of the classical belt's named giants, is the quiet one, and its story belongs as much to human history as to astronomy. It is a bit smaller than Pluto, reddish with tholins like so much of the belt, with a day about as long as ours and a year of about 306 Earth years, and for a long time it was thought to be moonless until a small dark companion turned up in Hubble images. But its name is the part I want to leave with you. When it was discovered, around Easter of 2005, its finders reached not for Greece or Rome, but for Rapa Nui, Easter Island, and named the world for Makemake, the creator god of the Rapa Nui people, the bringer of humanity. There is something quietly fitting in that. The most remote provinces of the solar system are being named world by world from the full breadth of humanity's imaginations. Hawaiian goddesses of childbirth for Haumea, Rapa Nui creators, and, as we are about to see, sky gods of the Tongva people of California. The belt is becoming, among its other distinctions, the most culturally diverse map in the solar system. A frozen country whose citizens carry the names of every people's oldest stories. Which brings us to Quawa, named for the creation force of the Tongva, the people of the Los Angeles Basin, and to one of the freshest mysteries in the entire belt. Quawa is a solid, mid-sized world, roughly half Pluto's width, with a little moon called Waywat. In 2023, astronomers watching Quawa pass in front of background stars, the occultation technique that does so much of the belt's science, noticed the starlight dimming briefly before and after the world itself crossed. Quawa has a ring. But this ring, unlike Haumea's, is in the wrong place. Every ring we had ever found, around every world from Saturn to Haumea, obeys a rule worked out a century and a half ago, the Roche limit, the invisible boundary close to a world inside which tides tear, clumps apart, and keep ring material as rings, and outside which the material should gather itself into a moon within mere decades. Quawa's ring circles far outside that boundary, at a distance where every textbook says it should have rolled itself up into a small moon almost immediately. And there it is anyway, a ring persisting where rings are forbidden, orbiting in apparent rhythm with the moon, Waywat, forcing theorists back to their blackboards to ask what else, in the deep cold, we have gotten subtly wrong. Whether ice out there collides too elastically to clump, whether resonances can hold a ring open where tides cannot. It is Neptune's lesson again, the one we carried home from our last night together, now repeated at the far edge of the map. The universe does not owe our expectations anything, and the third country, barely 30 years into its acquaintance with us, is already breaking rules we thought were settled. And we should not leave the giants without paying a call on the strangest household among them, the double world at the heart of the Plutino tribe. Pluto, as we said, does not really have a moon in Charon. It has a partner. Charon is over half Pluto's width, by far the largest moon in the solar system relative to its parent, so large that the pair pivot around a point in the open space between them, two dancers leaning back from clasped hands. Long ago, tides locked them face to face, and now each turns exactly once per orbit of the other, which produces a sky arrangement found nowhere else among the worlds we know. From the near side of Pluto, Charon does not rise, cross the sky, or set. It hangs, fixed, a great grey disk nailed to one spot in the heavens, 7 times the apparent width of our full moon, through every hour of every day of every century, while the stars wheel behind it. Generations of Plutonian mountains have eroded and reformed under a moon that has never moved a finger's width in the sky. And from Pluto's far side, Charon has never been visible at all, not once, ever. A whole hemisphere that does not know it lives in a double world. New Horizons, on its way past, gave Karen its portrait too, and the partner turned out to be worth the film. A deep canyon system gouged across its face, dwarfing our Grand Canyon, evidence of an ancient interior ocean that froze and cracked the world as it expanded, and, at its north pole, a vast, dark red stain unlike anything else in the solar system. The leading explanation for that stain is almost too good. Methane escaping from Pluto's atmosphere, thin as it is, drifts across the gap between the worlds, and some of it is captured and freezes onto Charon's winter pole, where the long darkness and the radiation slowly cook it into red tholins. Pluto is painting its partner, one world's escaping breath, settling on the other's brow, as a century-by-century blush, the most patient act of decoration in the sun's family. And beneath the named giants, the deep census keeps delivering quieter wonders. Gong Gong, a scattered disk world named from Chinese myth, red as rust, with a moon of its own. Orcus, the anti-Pluto, locked in the same 3-for-2 rhythm with Neptune as Pluto itself, but timed opposite, so that when Pluto is near the Sun, Orcus is far. Two counterweights on the same gravitational pendulum. Pluto's own household, which is not a planet and moon at all, but something closer to a double world, its great companion Charon so large relative to Pluto that the two orbit a point in the empty space between them, face locked to face forever, each hanging motionless in the other's sky. Binaries, families, rings, moons of rhythm. 30 years ago, this entire country held one known citizen. Tonight, no matter how faint the province, everywhere we have learned to look, the belt looks back with structure and story and personality. The third country is not a debris field. It is a civilization of worlds that simply never got large, still keeping the old customs of the solar system's first years, out where nothing ever arrived to change them. By now you may have noticed that one visitor keeps walking through tonight's story, and it is time to follow it, because the greatest single day in the exploration of the Kuiper Belt happened while most of the world was asleep on a New Year's morning, and it happened to a spacecraft we have already praised on another night for what it did at Pluto. New Horizons launched from Florida in January of 2006, the fastest departure from Earth ever flown at the time, moving so quickly that it crossed the moon's orbit in about 9 hours. And bolted inside it, riding in a small container on the spacecraft's inner deck, is a passenger, because the mission's designers understood exactly whose story they were finishing. The container holds a portion of the ashes of Clyde Tombaugh, the Kansas farm boy of our earlier hour, who died in 1997, 9 years before the launch, and whose family gave a measure of his remains to the mission. The inscription on the container calls him simply Discoverer of Pluto and the solar system's third zone. Think of the arc of that single human life and where it has ended up. The eyes that ached at the blink comparator in 1930, finding the first citizen of the third country in a swarm of stars, made the journey in person after all. Tombaugh has flown past the world he discovered, out among the country his discovery implied, and he is outbound through it tonight, the first human remains ever to leave for the stars, still traveling with the mission, his speck of light began. It reached Pluto in July of 2015 and gave the belt's first citizen the portrait we spoke of, the ice mountains and the nitrogen glaciers and the bright heart. But Pluto, for all its glory, was a flyby, and the spacecraft came out the far side healthy, fueled, and flying deeper into the third country at more than 30,000 miles per hour. The question was where to send it next, and that question, which sounds routine, nearly went unanswered, for exactly the reason this whole night keeps teaching: the belt is empty. The mission needed a body close to the spacecraft's outbound path, reachable with the small nudge its remaining fuel could buy, and after years of searching with the largest telescopes on Earth, the tally of candidates stood at 0. The most crowded country in the solar system would not offer one reachable stone. In the end, it took the Hubble Space Telescope, the sharpest eye humanity owns, dedicating weeks of precious time in the summer of 2014 to save the second act. Deep in those frames, moving at the correct creep, was a speck of the 27th magnitude, dimmer than a candle seen from millions of miles, a nothing, a rounding error of light. It was catalogued, targeted, and on the 1st of January 2019, after 3.5 more years of silent outbound flight, New Horizons swept past it at a distance of about 2,200 miles, and the speck became a world called Arakoth, a name from the Powhatan language meaning sky. It remains, to this night, the most distant object ever visited by anything built by human hands. More than 4 billion miles from home when the portrait was taken, so far that the radio confirmation of survival took over 6 hours to crawl back to Earth at the speed of light. And the portrait was worth every year of the hunt, because Arakoth turned out to be a message from the beginning of the world. The pictures show something almost comical at first glance: a reddish snowman, 2 rounded lobes joined at a narrow neck, the whole thing about 22 miles long, lying on its side in the dark. But look, with a scientist's eyes, and the comedy becomes scripture. 2 separate bodies formed side by side, orbited each other for an age, and then, with a gentleness that is almost impossible to picture at astronomical scales, touched. The estimated meeting speed was a walking pace, slower than you close a car door. No shatter, no crater, no violence at all. Just 2 primordial worlds leaning together until they held and staying that way for 4.5 billion years. The neck between the lobes is barely crumpled. Nothing about Arakoth has been melted, battered, or boiled since the solar system's first chapters. It is, by wide agreement, the most pristine object ever examined up close, an untouched construction brick still in its original packaging, and it settled a genuine argument. For decades, theorists debated how planet building begins, whether the first bodies grow by violent hierarchical collision, smash and merge and smash again, or whether they condense gently, clouds of pebbles drawn softly together by their own faint gravity until they become something whole. Arakoth's unbruised neck and matched, unshattered lobes are a quiet, 4-billion-year-old vote for gentleness. The worlds, it turns out, began softly. The first act of planet formation was closer to falling asleep than to a collision, which seems, tonight of all nights, like information you were owed. I want to take you inside that New Year's flyby properly before we leave it, because the encounter with Arakoth may be the most extreme act of marksmanship our species has ever performed, and the room where it happened is worth remembering. Consider first what the shot required: a target 22 miles long, which had been discovered barely 4 years earlier as a 27th magnitude smudge, its orbit known only from a few years of Hubble measurements out of a lap of roughly 300 years. A spacecraft the size of a grand piano, closing at over 30,000 miles per hour, with no ability to see its target meaningfully until the final days, and no second chance of any kind. The aim point was a keyhole about 2,200 miles from the body, timed to the second, 4 billion miles from the people doing the aiming, with every correction crawling out at light speed for 6 hours and every confirmation crawling 6 hours back. The team threaded it. In the first hours of January the 1st, 2019, while much of the world was still toasting the new year, the operations center in Maryland gathered around the screens for the signal that would report whether their spacecraft had lived through its own moment of glory, a moment that had, in fact, already happened 6 hours earlier, out in the dark, alone. That is the strange tense in which all deep space exploration happens, the past arriving as suspense. And there is one more detail from that night which I have always loved. Among the crowd at Mission Control was Brian May, the lead guitarist of the rock band Queen, who happens to hold a doctorate in astrophysics and who had composed an anthem for the flyby. When the carrier signal arrived on time to the second and the room stood and roared, the most distant appointment ever kept by anything human had been kept with a rock soundtrack and champagne. The snowman's portrait began arriving shortly after, line by line, and the third country had its second visited world. But here is the number from that encounter that best teaches what the third country actually demands of its visitors. The flyby itself was over in hours. Transmitting its results home took 20 months. New Horizons speaks across 4 billion miles with a transmitter of about a dozen watts, dimmer than a nightlight, and at that distance its data trickles to Earth at a rate slower than the dial-up modems of the early internet, a couple of thousand bits per second on a good day, received by dish antennas 70 meters wide, listening to a whisper thinner than a snowflake's worth of energy. Every stored image and spectrum from those few hours of glory had to queue in the spacecraft's memory and drip home day after day through all of 2019 and most of 2020. Think about what that means for the shape of the achievement. The men and women who flew the encounter then spent nearly 2 years unwrapping it, one thin strip of data at a time, the world's slowest developing photograph, each morning's downlink adding another sliver of the snowman. The belt does not only make you cross 4 billion miles to visit it, it makes you wait 2 more years to hear the whole answer. Patience, always patience, at every layer of this country's story, from the 5 empty years of Jowett and Lou, to the decade of outbound cruising, to the 20-month whisper home. The Kuiper Belt has never once been in a hurry, and it does not permit its visitors to be. And because New Horizons is the only working camera ever stationed in the third country, scientists have put its vantage point to one more use, a measurement so fundamental it sounds like philosophy. They have used it to ask how dark the universe is. Here on Earth, and everywhere in the inner solar system, that question cannot be answered, because we live inside a permanent soft glare, sunlight scattering off the fog of interplanetary dust that fills the space between the planets, a haze of false light that no telescope can subtract with confidence. But out past Pluto, the dust thins and the sun dwindles, and the sky as seen by New Horizons is the truest dark any instrument of ours has ever occupied. So, in the cruise years after Arakoth, the team turned the spacecraft's camera on patches of nothing, fields chosen for their emptiness, and measured the faint glow that remained after every known star and galaxy was accounted for. The collected shine of the whole universe, the sum of all the light from everything, everywhere arriving at one dark place. That number, the cosmic optical background, is one of cosmology's quiet grails, a census of every fire that has ever burned. And our best measurement of it now comes from inside the Kuiper Belt, because the belt is the darkest observatory humanity owns. I love what that does to tonight's geography. The third country is not only the solar system's attic and its comet cellar, it is its dark room, the one place quiet enough and black enough to develop a photograph of everything. And the science that came down that slow wire rewrote the textbook on beginnings. So let us give the revelation its full shape, because I promised you earlier that Arakoth settled an old argument, and the argument deserves to be understood properly as you drift. The puzzle is called the meter barrier, and it haunted planet formation theory for decades. Making a planet means growing from dust grains to worlds, and the mathematics handles the two ends of that journey beautifully. Dust sticks to dust electrostatically, no problem up to pebble size. And once a body is a mile wide, its own gravity takes over the collecting. No problem from there to Pluto. The catastrophe is the middle. Objects around a meter wide, boulder-sized, are too heavy to stick electrostatically and far too light to attract anything gravitationally. And worse, at that size, the drag of the young solar system's gas should have sent every boulder spiraling into the sun within mere centuries. By the old violent picture of growth, nothing should ever have survived the middle. The modern answer is called the streaming instability, and it is a beautiful piece of physics that amounts to this. The boulders did not grow through the barrier, they crowded through it together. In the young gas disk, drifting pebbles bunch, the way cyclists bunch into pelotons, each rider sheltering in the next one's slipstream. And the bunching feeds itself until a swarm of pebbles millions of miles long becomes dense enough to feel its own collective gravity and gently collapses, the whole crowd at once, into a body tens of miles wide in a single astronomical instant, skipping the deadly middle sizes entirely. That theory made a hard, testable prediction. Worlds born by gentle collective collapse should often form as orbiting pairs. They should be built of matched material, and if two partners ever merged, they should have met at drifting speed, unbruised. Then, humanity flew 4 billion miles and photographed the oldest untouched object it has ever examined, and there it was. Two matched lobes. A binary that closed the last of the distance and touched at a walking pace. An unbroken neck. Arakoth is the streaming instability's signature, written in ice and left unsigned for 4.5 billion years at the bottom of the solar system's oldest drawer. The couples of the cold classical belt, or those pairs holding hands, are the same signature repeated across an entire province. Worlds are born in crowds, gently holding on to each other. We know this now with our eyes because of one slow whisper from a piano-sized machine at the far edge of the map. Arakoth also answered in passing a question you may have been holding since we described the Belt citizens as deep, frozen leftovers. What are they leftovers of, exactly? What is the Belt for in the economy of the solar system? Part of the answer streaks through our own skies every year. Remember Fernandez's bookkeeping, the argument that short-period comets must be resupplied from a flat reservoir beyond Neptune. That reservoir is the Belt, and above all its scattered disk province, the badlands of thrown worlds. Out there, Neptune's gravity is still working the borders, and every so often over the ages its slow tugging tips one of the scattered bodies onto a path that dips inward. Handed from giant to giant, warmed for the first time in billions of years, the body's ancient ices begin to boil off into the vacuum, and it grows the glowing head and streaming tail our ancestors read as omens. A comet, at the root of it, is a defector from the third country. Every Jupiter family comet in the catalogue is a piece of the Kuiper belt on a long, doomed embassy to the warm rooms of the inner solar system, shedding its 4 billion-year-old frost into our skies a ton at a time. When you have seen a comet, and some night of your life you will, you have seen the belt with your naked eyes, delivered to your doorstep. And our own Neptune night gave us the aristocrat of this defector class, remember, though it travelled in the opposite sense. Triton, Neptune's great backward moon, the stolen world, is a captured citizen of this same country, a Kuiper belt native of Pluto's own rank, taken hostage at the border in the deep past. The belt does not merely neighbour the planetary realm, it staffs it. It has been sending emissaries inward, willing and unwilling, for the whole life of the solar system. And one of those emissaries, it is worth remembering, has already received humanity in person in one of the great encounters of the space age. In 2014, the European spacecraft Rosetta arrived at a comet called Churyumov-Gerasimenko chased it down after a 10-year flight, circled it for 2 years, and set a small lander on its surface, the first soft landing on a comet in history. The world Rosetta found was a revelation, a black, duck-shaped body of 2 lobes joined at a neck, venting its ancient ices in jets as the sun warmed it, layered like an onion, richer in organic chemistry than anyone had dared predict. And its family tree points exactly where you now know to look. Churyumov-Gerasimenko is a Jupiter family comet, one of Fernandez's flock, and its orbit is the signature of a body that spent most of the age of the solar system asleep in the region beyond Neptune before the long relay of the giants handed it inward. Now hold its portrait beside Arrokoth's. 2 lobes, a neck, a gentle, ancient join. The resemblance is not a coincidence, and scientists noticed it immediately. The duck and the snowman are the same kind of object at 2 ends of one long story, siblings from the same cold nursery, one still lying pristine in the deep freeze where it formed, the other pulled down the stairs into the warmth, blistering and shedding its substance a little more with every pass around the fire. When Rosetta's comet finally crumbles some centuries or millennia from now, the belt will already have dispatched its replacement. We have now stood on both ends of that pipeline, walked the warehouse with New Horizons, and ridden the delivery van with Rosetta, and the 2 visits agree on everything that matters. The third country is made of beginnings, and it has been quietly mailing them inward forever. But the deepest thing the belt tells us about the solar system's economy is written not in what it contains, but in what it is missing. And here we arrive at one of the great open puzzles of the third country. Count everything. Add up Pluto, Eris, Haumea, Makemake, Quaoar, the hundreds of thousands of lesser bodies, the trillion comets, every crumb of the belt we can detect or infer, and weigh it all together. You get a number that should be embarrassing to somebody. The whole Kuiper belt, the largest structure in the solar system, weighs in at only a small fraction of the mass of the Earth, by most modern estimates just a few percent, and by some, less than that. Now here is the problem. The belt manufactured worlds. Pluto exists. Eris exists. Bodies hundreds of miles across exist by the hundreds of thousands, and the mathematics of accretion the same gentle pebble-gathering Arrokoth vouched for simply cannot build objects that large out of a disk as thin and starved as today's belt. Grown in the present belt, nothing bigger than a modest boulder should ever have assembled. For Pluto and its peers to exist at all, the original belt must have been rich, by most models 10s of times the mass of the Earth, hundreds of times its weight today. Which means the third country we have been touring all night is not the thing that was. It is the ruin of the thing that was. Somewhere in the deep past, 99% of the Kuiper belt went missing, and the leading suspect by now will not surprise you. When Neptune made its great outward migration, ploughing slowly through the young belt's riches, it did not merely comb the survivors into rhythmic tribes and fling the scattered disk to the badlands. It emptied the treasury. World after world, the migrating giant's gravity caught the belt's substance and dealt it away. some inward toward the fires, some out to the far darkness, some into the beginnings of that vast spherical comet cloud at the true edge of the sun's holdings, a place we will spend a different night with someday. The stately, quiet belt of tonight is the aftermath of the greatest clearance in solar system history, a nation that once outweighed worlds reduced to keepsakes and survivors. When you picture the belt now, picture that, not a warehouse never filled, but a great hall after the fire, the surviving heirlooms spaced out along the walls, and Neptune at the door 4.5 billion years later, still slowly turning the key. There is one more mystery to visit before we turn for home, and it lives at the far wall of the third country. Because the Kuiper Belt does something at its outer boundary that nobody predicted and nobody has fully explained. It stops. Follow the belt outward from Neptune's doorstep, through the resonant tribes, across the cold classical heartland, and the census stays rich, province after province, all the way out to about 50 yardsticks from the sun. And then, within a startlingly short distance, the population of ordinary belt objects collapses. Astronomers call it the Kuiper Cliff, and the name is apt. It is not a gentle thinning, the way a city fades through suburbs into countryside. It is an edge, as though the country had a wall. And it is backwards from every expectation. Out there, farther from the sun, Neptune's disturbing gravity is weaker, not stronger. The primordial disk should have extended on, and the models that build the belt in the first place mostly agree that material should continue well past 50 yardsticks, thinning gradually. Instead, a cliff. Why? Perhaps the sun's birth nebula simply ran out there and the wall is original, the actual hem of the cloth we were all cut from. Perhaps another star, passing close in the sun's crowded stellar nursery 4.5 billion years ago, sheared the disk's outer edge away in a single ancient encounter, and the cliff is a scar from a meeting no witness survived to describe. Perhaps the material beyond 50 yardsticks is still there, but assembled differently, ground down or grown up into bodies too few and faint for our present censuses. And yes, some astronomers have wondered aloud whether something massive orbiting unseen in the far darkness has been quietly sweeping that outer shelf clean. A hypothesis, you may remember, occupied us for an entire night once. The night we went looking for the something tugging at the edge of the solar system. Tonight, we simply note the connection and set it down. Whatever the answer, primordial hem, ancient scar, hidden shepherd, or a census still too shallow, the belt keeps its far wall, and the far wall keeps its secret, and the secret is now one of the outstanding unsolved problems of the outer solar system, standing in plain sight at the edge of the map, patient as everything else out there. And the wall, it turns out, is not truly the end either, because the belt has outskirts and the outskirts have citizens stranger than anything within. Beyond the cliff, on orbits so vast and detached that even Neptune's long arm cannot claim credit for them, drift the far wanderers, and their queen is Sedna, a reddish world discovered in 2003, whose orbit is unlike anything else we have charted. Sedna never comes closer to the Sun than about 76 yardsticks, half again the belt's far wall, and at the long end of its lap it recedes to nearly 900, so deep into the dark that its year lasts on the order of 11,000 Earth years. When Sedna last rounded the Sun, humanity was inventing agriculture. Nothing in the known solar system can explain how it got there. No planet reaches it, no rhythm conducts it, and every proposed answer, a lost sibling star of the Sun's youth, a stellar flyby, an unseen distant shepherd, rewrites some page of our history, if true. And Sedna is not entirely alone out there. In the years since, the surveys have caught a small handful of companions, a second far wanderer found in 2012, others trailing after, each with the same signature, orbits detached from every known planet's reach, near points clustered suspiciously in similar quarters of the sky, as though something had arranged them, or once arranged them, and the sample is still so small that nobody can say whether the clustering is a message or a coincidence of a census barely begun. Astronomers have started calling this thin, scattered population the sednoids, and every new one found is an event because each is another data point in the solar system's outermost unsolved geometry. Sedna and its companions are the whispered hint that between the Kuiper Belt and the Oort cloud, the solar system may keep yet another population we have barely begun to count, a fourth country beyond the third. We will not cross into it tonight, but know, as you drift, that the map does not end at the cliff any more than it ended at Neptune. The lesson of tonight has no far wall. There is always another province past the last one, all the way out to the edge of the Sun's gravity, a quarter of the way to the nearest star. Will we ever do better than flybys and blinking stars? Someday. And the engineers already know what it would take, because they have run the studies, and the studies read like a lesson in humility. To actually orbit a Kuiper Belt world, to circle Pluto or Eris for years the way we have circled Saturn and Jupiter, you must solve a cruel arithmetic. The belt is so far away that reaching it in any reasonable time means arriving at tremendous speed, and orbiting means shedding all of that speed at a destination whose gravity is too feeble to help you brake, around which there is no atmosphere thick enough to drag against, with a sun too dim to feed solar panels, on a fuel budget that must be carried every mile of the way out. Chemical rockets cannot close that circle. The mission concepts that work on paper lean on technologies still maturing, nuclear electric engines that thrust gently for decades, and even then the timelines humble every calendar they touch. Decades of crews, arrivals scheduled for the 2050s and beyond, missions whose principal investigators would be handing them to successors not yet in graduate school. Nobody has approved such a mission. The belt's second visitor, whenever it flies, has likely not been built, and its designers may tonight be children. That is not a lament, by the way. It is the belt keeping its own tempo, as it always has. A country whose seasons last 40 years and whose citizens have waited 4.5 billion of them does not measure our decades the way we do. The belt will still be there, unchanged to the last snowfield whenever we manage to return, and it would find nothing remarkable in the wait, which is why it matters that this story is not finished and is in fact accelerating right now in the very year you are falling asleep in. 30 years after two patient astronomers found one moving speck, the discovery machinery has finally caught up to the belt's scale. In the mountains of Chile, the Vera Rubin Observatory, carrying the largest digital camera ever built, began its great survey of the sky in the middle of 2026. And over the coming decade, it is expected to photograph the entire visible heavens every few nights, deep enough to multiply the belt's known census many times over. Tens of thousands of new citizens, new dwarf planets, almost certainly among them, new far wanderers of Sedna's tribe, and, one way or another, the strongest test yet of what does or does not lurk beyond the cliff. The blank third country of your childhood map is about to become one of the best charted regions of the solar system within the lifetime of everyone listening tonight. And it will not happen as one dramatic announcement. It will happen the way the belt does everything, gradually and in bulk, night after night of automated alerts, moving specks flagged by software, orbits firming up over months as the observations accumulate, license plates piling up in the catalogues by the thousand, faster than any committee can ever name them. Somewhere in the first years of that flood, statistically the surveys should catch worlds to rival Eris and Pluto if they are there, and the far wanderers of Sedna's tribe should multiply from a handful to a population, and the question of the clustering, message or coincidence will finally have enough data points to answer itself. The people who will make those discoveries will mostly never look through a telescope at all. They will be reading software cues over morning coffee, the blink comparator reborn as an algorithm, Tombour's aching year compressed into a nightly automated pass over the entire sky. The method changes. The patience just relocates. And the country's one visitor is still out there, still working. New Horizons, healthy and flying, is outbound through the belt's far provinces as you lie here. Its instruments still tasting the dust and the particle winds of the third country from inside it. Its team still hoping the great new surveys will hand them one more reachable stone before the fuel and the years run out. Someday, like its elder cousins the Voyagers, it will cross the boundary where the sun's breath gives way to the breath of the stars and fall silent and keep going anyway. But that is for another decade. Tonight, it is still ours, still in the belt, the only machine of ours that has ever touched this country, 4 billion miles from the room you are lying in and moving farther every second, entirely at peace with the size of its errand. There is a final widening of the lens that the belt has earned tonight before we fold the map, because the third country turns out not to be a local eccentricity. It is a family trait. When astronomers point infrared telescopes at other stars, young ones and old ones alike, They keep finding the same cold signature glowing faintly around them, vast rings of chilled dust far outside the orbits where planets shine, dust that can only be the grinding powder of colliding icy bodies. Around the brilliant southern star Fomalhaut, telescopes have imaged a great sharp-edged ring of debris, so crisply sculpted that its shape is read as the work of unseen shepherding worlds. Around Vega, one of the brightest stars of the northern summer sky, a cold belt glows far out where our own belt would sit. Dozens upon dozens of nearby stars wear them, and the fair reading of the census is that belts like ours are not rare furniture. They may be part of the standard kit of a planetary system, the ordinary hem left over wherever a star finishes cutting its worlds, which turns tonight's whole journey inside out in the loveliest way. Some night, on some world circling Fomalhaut or Vega, if anyone is there to lie awake, their astronomy has a chapter about us. Our Kuiper belt, ground gently into dust by its own slow collisions, shines at their infrared telescopes exactly the way theirs shine at ours, a faint cold ring around an ordinary yellow star. And everything else we spent tonight with, the couples holding hands, the egg with its ring, the snowman, the whole third country, is compressed for them into one soft, unresolved glow at the edge of our light. Every belt we see around every other star is somebody else's tonight, waiting to be toured. The universe, it seems, finishes all its houses the same way and leaves the builder's yard standing at the edge of every one. Closer to home, the belt's chemistry has just come into focus for the first time, because the Webb telescope, the same great eye that gave us Neptune's rings on our last night out, has begun taking proper spectra of Kuiper belt worlds, reading their surface chemistry across 4 billion miles, with a fidelity no instrument has managed before. The early results have delighted the chemists. Carbon dioxide ice spread across the belt far more widely than expected. Methanol, wood alcohol, frozen onto distant surfaces, a molecule partway along the road from simple ice to complex organic chemistry. Surfaces sorting into chemical families that track their orbital tribes, natives and interlopers wearing different coats, just as the migration histories predicted. World by world, the census is acquiring a chemistry column, and the third country is turning out to be not a uniform frost, but a patchwork of recipes, each surface a page from a different chapter of the solar system's cookbook. And the yard is not merely a monument because there is a fair case that you are personally acquainted with its stock. The Earth formed hot, close to the sun, in a zone where water struggles to stay attached to rock. And yet, here we are, on a blue world, oceans deep. Where the water arrived from remains one of the genuinely contested questions of planetary science, and the icy bodies of the outer system have always been among the leading suspects. In the era of the Great Migrations, when Neptune's wanderings were emptying the primordial belt's treasury, the solar system ran a bombardment in both directions, and some fraction of the outward country's substance, its water, its carbon, its nitrogen, its frozen organic chemistry, was dealt inward and delivered onto the young rocky worlds by impact, a rain of the third country onto the first. How large that fraction was, whether the decisive deliveries came from the asteroid belt's icier members or from the true outer dark, the chemists are still arguing, isotope by isotope, and honesty requires tonight to leave the verdict open. But the softer statement stands on firm ground. The materials of the outer country and the materials of life share a family resemblance that is not a coincidence. The same water, the same carbon compounds, the same nitrogen that fills your lungs twice a breath. The belt is built of the solar system's original volatile stock, and so, in some meaningful part, are you. When we called it the attic where the building materials are stored, that was not only a figure of speech. Some of the shipment came down the stairs long ago, and tonight it is reading and breathing and falling asleep. Now, as we finally turn for home, let us fold the new map and see what we are actually holding, because tonight was never really about icy rubble at the edge of things. Start with the count. For most of human history, the solar system had 5 wandering lights and an edge you could see with your eyes. Then it had 6 planets, then 7, then 8, each enlargement a small scandal, each new edge mistaken for the final one. Then a Kansas farm boy found the 9th light, and for 62 years the map said, finished, right up until an August night on a Hawaiian mountaintop when a single faint dot refused to hold still, and the solar system turned out to be mostly unexplored. That is the actual shape of our neighborhood, as best we can now draw it. The planets, all of them, every world you memorized as a child, are the inner courtyard. Around them, from Neptune's doorstep outward, spreads a country as wide as everything they occupy, holding hundreds of thousands of worlds we have catalogued, and 1 trillion we never will. The original stock of creation in cold storage, couples that formed holding hands and never let go, eggs with rings, breathing worlds asleep under their own fallen skies, all of it the surviving remnant of a treasury Neptune spent building the order we live inside. Our own planet's water may carry some part of its signature. Our skies borrow its comets. Our one visit to it rewrote what we know about how worlds begin. And we have known any of this for barely 30 years, which is to say, we have lived our whole civilization inside a solar system we only just met. So here, at the end, is tonight's cascade, the things worth keeping as sleep comes up around you. They said the region beyond Neptune was empty, and it held the largest structure the sun owns. They said Pluto was an oddball, and it was the first citizen of a nation. They said the word planet was settled, and a world named for discord unsettled it. They said rings could not survive where Quawa keeps one anyway. They said the first act of world building must have been violent, and Arakoth held up its unbruised neck, gentle as 2 hands meeting, and said otherwise. Every rule we carried out past Neptune came back corrected, and every correction made the solar system larger, older, stranger, and somehow calmer than the one we thought we lived in. The universe does not guard its edges, it just waits past them, patiently holding more. Thank you for coming out to the third country with me tonight, out past the last planet, across the quiet provinces to the cliff at the edge of the census. If sleep is close now, let it be close. There is nothing here to finish and no part of tonight that will not keep. The belt has waited 4.5 billion years without once being in a hurry, and it will hold everything exactly where it is while you rest. And tomorrow night, or some clear night soon, when you happen to glance up before turning in, you might remember what is actually up there, spread behind the visible stars in a great, silent ring. The couple's still holding hands, the egg still turning once every 4 hours wearing its ring. Eris, under its fallen sky, waiting out the centuries for its distant spring. The little snowman lying on its side in the dark, unbruised since the beginning of the world, and threading out among them a small nuclear heart and a dish antenna, our one emissary, still awake, still leaving, carrying a Kansas farm boy's ashes past the worlds he was the first to suspect. The sky above your roof does not end where the streetlights fade, and the solar system does not end where the planets do. The map goes on past every edge anyone has ever drawn on it. So can the night. Sleep well, somewhere in the inner courtyard of a country that is mostly still unopened. Good night.